Hello, ladies and gentlemen. Greetings. Power electronics analysis. We are going to be focusing on resistive and battery charger as a load. In power electronics, we focus on three types of loads: the resistive load, the inductive load, and the battery charger. I would like to focus on resistive and battery charger as a load on this topic and on this session I'm having, because I have so many questions on certain challenges and problems and difficulties that some of the audience are facing. So I want to clarify or try to simplify it to facilitate it, those challenges and those problems. Those are minor problems, but you just need some explanation on it to get it clear. So that's exactly what I'm about to do. So in brief, when we talk about resistive loads, we know that with resistive loads, we are talking about the voltage and the current they are in phase. That's a unity power factor. We don't have discharge angles like what you're going to present in inductive loads or battery charger. You have some curve for discharges. With resistive loads, is unity. Well, I would like to go straight to the point when we're talking about the resistive and the battery charger as a load. Here, we cannot deal without some basic knowledge of trigonometry or some form of mathematical derivation which we need to go through. But first of all, some of the terminology we are already versed with it, and normally the symbols for the circuit diagram representing half wave rectification, full wave rectification, we are already versed with it. So normally when we are dealing with power electronics, we are working with bridges, half wave or full wave rectification, and the sinusoidal waveform. You can be using the cosine waveform or the sine waveform. But our main supply, we are using the sine waveform that we are using to derive our equation or the expressions that we are going to be using for full wave and half wave rectification. With the challenges I've gotten from that the students or the audience are complaining about certain challenges when it comes to resistive and battery charger as a load, I want to present some questions here where within those questions we are going to have those challenges, or we are going to tackle the challenges that they are going to clear off our doubts. So right away, I would like to present a question here. that the question is going to contain practically all of our challenges. And with those questions now, once we are analyzing on it, those slope holes that we are having problems with it, or those challenges that are going to be solved. So right away with the question: power electronics analysis, resistive and battery charger as a load. So from the question, as the question goes there, you can get it, you can read the question there. So practically I will have to take the question one after another and be analyzing on it. So you just try to go through the question, and as you are going through the question, I will pick it one after another and do some analysis on it. Okay, that notwithstanding, we must write on. From the first question, you will get it. It says, draw the circuit diagram showing the direction of current in each branch. From the question, we are talking about full wave rectification. And with full wave rectification, we are talking about a bridge of 4 diodes. 4 diodes. From the diagram, you can see the 4 diodes. We have D1, D2, D3, and D4. You can find the direction of the current on the individual branches, I1, I2, and IL. We have our voltage supply, V1. I would just like to go further, like to give a little bit of further explanation, like the conduction or the operation, the principle of operation, how it functions. Normally, our supply network, the sinusoidal waveform that we are going to be using, we have the positive half circle and the negative half circle. We are working with a frequency of 50 hertz. One circle is made up of positive and the positive half circle and the negative half circle. The positive half circle, we're talking about pi, which is equal to 180 degrees, while the complete circle is 360, which is equal to 2 pi. So if you are looking at it within the positive half circle, from the diagram that you are seeing, D1 and D4 will be conducting. Why D1 and D4 are conducting means that they are acting like close switch at that moment. Why at the negative alternance, D2 and D3, they are open, they are not conducting. So at that moment, when we are working within the positive alternance, you can find the load to receive current. We are going to, the I1 is going to be present. There will be voltage across the load. So that's the diagram. When they say we should draw the circuit diagram showing the direction of current in each branch, we have identified I1, I2, and I and IL. So if we go to the next question, or please, if you have not gotten it or it's not clear, you just inbox me and you drop your difficulties where you have your challenges there, then we are going to look at it later. The next question is talking about draw the waveform of A, the voltage across the load, and that of the diodes, and that of each diode, and the current through the load and the diodes. From the presentation of the diagram, which we'll see here, we have our normal supply waveform. Our normal supply waveform, which we can see, we have the normal positive half circle and the negative half circle, which make a complete one circle. If you have to go further, you go further. Now we have the voltage across the load. The voltage across the load, when you look at it within the positive half circle or the positive alternance, you will find Z1, 4. That is the diode Z1 and Z4 will be conducting during the positive alternance. That's why you see it shows that the load is going to receive power. During the negative alternance, you find D2 and D3 are conducting. So it means that the load will be receiving power all through, because it's not a half-wave rectification. If it was a half-wave rectification, within the negative alternance, the load is not going to see power. So that is the diagram for the load across the voltage across the load. If we have to go further now, we want to look the voltage across the diodes. The diodes are working in pairs. So within the positive alternance, that's the positive half circle, we have diode D1 and diode D4 that will be conducting. So if you look from the waveform is with respect to time. We are working the sine waveform with respect to time. So if you see it, you look at it critically, you will see within the positive alternance, as the diode is acting like a closed switch, you see it is closed. There is power there. Why? At the negative alternance wait, it's not yet time for the circle, for the negative half circle, the positive alternance. At the moment where you have the negative alternance, there is no voltage there. So that's why you find the complete circle, the complete negative half circle for the negative alternance is present there. So diode Z1 and D4 are conducting from the diagram you see. So up to this level yet, if you have understood, or to prove to me that you have understood what we have been saying till this moment, I would like you to come out with the diagram or the waveform for the current across diodes D1 and D4. Thanks for listening and thanks for watching. We are going to continue from there next time. And please, for any difficulties, please inbox me or let me know your challenges or your difficulties. Thank you.